All right, welcome back, everybody. Today we're going to be talking about section 3.4. This is really like day 2 or B. Our objective is that we're going to be able to solve exponential equations. So let's take a look at how this goes. So a couple different things. Obviously, one of the more important pieces is how we switch from a logarithm to an exponent, right? Remember that log base a of n being equal to x is the same thing as n being equal to a to the x. We're going to use that property quite a bit today. If we see a logarithm without a base, we can think about it as base 10, which we see over here in the exponential version of it. And if it's the ln, it's really base e is kind of what's going on. E to the x is equal to n. So coming over here, a couple of strategies that we are going to invoke today is get it down to one log or natural log. Isolate and solve by rewriting it in exponential form. So that's going to be our primary way to do this. Option number 2 is to get one log equal to another log and then to cancel and solve. In both cases, you will need to condense the expression if necessary. So looking at this first expression here, we see that we are log base 2 of x plus 5 is equal to 4. So we just want to rewrite this in our exponential form. So 2 to the 4th is equal to x plus 5. 2 to the 4th is 2 times 2 times 2 times 2, which is 16. So 16 is equal to x plus 5. And then we can subtract 5 from both sides, and we'll find out that x is equal to 11. Right? And that's really all that we need to do to solve that. So looking at another one here, this one obviously looks a little bit more intense. But when we realize that this is just a coefficient, meaning it's the exponent, same with this, it looks a little bit simpler. So we'll end up with log base 2 of x plus 2 to the second power, is equal to log base 2 of 2 to the 6th power. Now, the nice thing about this is that these are both log base 2 and log base 2. And if they're equal, the only way that can happen is if this actually equals this. So we can set this up. X plus 2 squared is equal to 2x. Let's find the value of x that makes those two equal to one another. So multiplying this one out, x plus 2 times x plus 2, that's what it means to squared. We get x squared plus 4x plus 4 is equal to 2 to the 6th power is, let's punch that in, I'm not exactly sure, 64 maybe? 2 to the 6th is 64. And then we can come over here and solve. So this is a quadratic, so we want to subtract 64 from both sides. So I'll be at x squared plus 4x minus 60 is equal to 0. Since we have a quadratic, we should try to factor this at this point. So factors of 60 would be 6 and 10. I think I can make those work. So I'd have x plus 10 and an x minus 6 would make that work out, which means my two solutions would end up being x equals negative 10 and x equals a positive 6. Now, the nice thing about this is that we can't ever take the natural log or log of something that's negative, so we cross out the one with the negative right here. We don't consider that one, and x equals 6 will be our final answer. Looking ahead at another problem here, so I'm going to pull my calculator to the side in case I need it again. Here's another one. So first thing we want to do is divide off by that 4 on both sides. Makes that disappear. We're going to be left with log, this is base 10 if we don't see it, of 3x is equal to 3. Now, some people choose to put that in the exponent, which is fine, but you would deal with it later down the road. Now, when we rewrite this over here, I'm going to get 10 to the 3rd power is equal to 3x. Well, 10 to the 3rd power is just 1,000. So I'm going to have 1,000 is equal to 3x. And then dividing both sides by 3, I find out that x is equal to 333.3 repeating. So that would be my answer for this problem. Looking down here at the next problem, here we see that we have kind of a log on both sides. So what I want to do is, it wouldn't make sense to try to divide by 3 in this situation. So I'm going to move this up to the exponent like I'm allowed to do. So I will have the log, this is base 10, of x to the third is equal to log base 10, if we don't see it, of 125. Since these two things are both log base 10, the only way that can happen is if x to the third is equal to 125. So setting up a new equation, x to the third equals 125. Solving this, well, actually, 125, if you look at this, or I guess a way to solve this would be to take the cubed root of both sides, making this and this cancel, which means x is going to be equal to the cubed root of 125. If you forget to do it, you can actually do it using the math option on your calculator, selecting the third root and typing in 125, and you find out that x does in fact equal 5, which is our answer. Coming over here, looking at our next problem, here you can see that we have two logs on one side. So we're going to need to put those logs together and condense them. So to condense these, we'll have log, remember subtraction means divide, of 1 over 3x minus 2 is equal to the log of x. Since these are just both log base 10 and we have logs on both sides, the only way that can happen is if this and this are equal. So we set up a new equation in which that is the case. Now, to solve this, what I would suggest doing is I would multiply both sides by 3x minus 2, because that's going to undo this division and cancel that off. So on the other side, I have to still multiply by 3x minus 2 to keep it balanced. So it'll be at 1 equals, now if we distribute this out, I'm going to get 3x squared minus 2x. And then to finish solving this thing, let's pull the 1 over to the other side. So I'll be at 0 is equal to 3x squared minus 2x minus 1. Now, you can try to do this a couple of different ways. You could try to factor this if you wanted to. So factoring, I would try to take 3 times 1. I would get a negative 3 up top and a negative 2 on the bottom. I think I can make that work. Two numbers that would multiply to give me a negative 3 would be a negative 3 and a positive 1. Those would add. So again, my method is the box method. So coming over here, I'll have my 3, my negative 1, my negative 3, and my positive 1. Factoring out a 3, I get a 3. 1, negative 1, and 1. So my factors would be 3x plus 1 and 1x minus 1, both equal to 0. Now our job is just to solve to figure out the x values that make that true. So if I had 3x plus 1 equals 0, subtracting 1, I get 3x is equal to a negative 1, and then divide by 3. X is equal to a negative 1/3 is one answer. For the other one, 1x minus 1 equals 0, add 1 to both sides, x equals 1 is my answer. Remember, reject the negative 1. This one goes away, and this is our answer. Looks like we have a couple more problems here for sure. 1, 2, 3, 4. So we'll keep rolling through these. So again, this one only has one log, so we should try to isolate. So I'm going to subtract this 7 from both sides. So I'll have 3 log of x is equal to a negative 1. Now I'm going to, you could look at this a couple of different ways. I think this time I'm going to move the 3 up into the exponent here. So this is the same as the log of x to the third, negative 1 there. Now when we look at this thing, remember that if I don't see a base, it's implied to be base 10. So this would be 10 to the negative 1 is equal to x to the third over here. 10 to the negative 1 is just 1 over 10 is equal to x to the third. And then, of course, to solve this, to undo cubing something, you need to take the cubed root of it. So taking the cubed root of both sides, I would end up with x being equal to, let's just call it the cubed root of 1/10. And we'll call that good enough. That is what x equals in this problem. Looking at this next one over here, again, we see 2 logs over here, so we're going to need to combine those together. So combining those together, since they are, it's addition, we would need to multiply those. So x plus 3 times x. And that's going to be equal to the log of x plus 3. Since we have 2 things that have the same log here, We know the only way that that's going to be equal is if the left side equals the right. So I'm going to get my x plus 3 from the left side is equal to x plus 3 times x. So to solve this, I would start by coming over here and distributing. I'm going to get an x squared plus 3x. And then I'm going to move everything over. So I'm going to subtract x and subtract 3 to get it equal to 0. So subtracting x and subtracting 3. We'll get x is equal, or I'm sorry, we'll get actually a 0 on this side equals x squared minus 2x minus 3. Again, we should try to factor here. So trying to factor this, we'd get a negative 3 and a negative 2, which would be a negative 3 and a positive 1. Since there was no a term, this would be an x minus 3 and an x plus 1. So when I come over here and I actually try to solve this now, remember that means my two solutions would be x is equal to 3 or x is equal to negative 1, and we reject the negative 1, making our answer just equal to 3. Looks like we got just a couple more problems here. So looking down here at this one over here, kind of see we got a couple different things going on here for sure. I do see that I have two log base 4s here. So I think what I'm going to do is I'm going to regroup those onto the same side. So I'm going to have 3 log base 2 of x minus 1, and then I'm going to have plus log base 2 of 4. I moved this over to the other side using addition, is equal to 5. Now we can try to condense these together. The 3, of course, is going to move up here to the exponent. So when I actually try to condense these together, I'm going to have log base 2 of, these are addition, so they're multiplied, x minus 1 to the third times 4 is equal to 5. So coming over here to solve this thing, we kind of have a little bit of work to do. So we're going to have 2 to the 5th power, when I rewrite this, is equal to x minus 1 to the third times 4. So to solve this, I think my approach would be, let's look at 2 to the 5th. 2 to the 5th ends up being 32. X minus 1 to the third times 4. We can unhook that 4 using division. So let's divide both sides by 4. So I'm going to be at 8 over here. X minus 1 to the third. To undo the cubing of it, we can take the cube root. So cube root. The cube root of 8 is just 2. So I'm going to get 2 is equal to x minus 1. Adding 1 to both sides, x has to equal 3. That's like a really complex solving, but it really just stems from your ability to realize that these two things have the same base. So let's get them onto the same side where we can condense them, and as soon as we can condense them, then we can kind of start rolling with stuff. Last problem we're going to look at right here, solving for x. So remember, whenever you see the natural log over here, it's nothing really to scare you in this situation. If you're more comfortable thinking about that as log base e, you can definitely replace that. I kind of like that idea right here because it's easier for me to just see my base. So I can rewrite this as e to the 6th is equal to x plus 3. So to get x alone, I would just need to subtract 3 from both sides. So take whatever e to the 6th is and minus 3, and you have x. I don't think it's important to actually get e to the 6th as a number in this problem. I think because it's going to be like non-repeating, non-terminating, I think I would leave it right there. Thank you guys so much for watching. If you do have any questions on this, and I'm sure you will, please don't hesitate to reach out. I'm always here to help you figure out what doesn't make sense. So if you need anything, please reach out. Have a good day.